Welcome to Chapter 9. Today we're starting with the first section of Chapter 9. In general, this chapter is about something called conic sections, which we'll introduce in class. But the first section talks about the midpoint and distance formulas, which are a pretty basic review from geometry, but a lot of the formulas that we'll be using in this chapter to talk about parabolas and ellipses and circles and hyperbolas are based on midpoint and distance formulas. So in the past, we've done slope of line. So now we're going to review basically the midpoint and distance formulas between 2 points. So hopefully this will be a pretty straightforward section. Remember, the midpoint formula looks like this. If I'm on the coordinate plane, here I have my segment PQ. This is a throwback to geometry, right? The midpoint means that it divides that segment into congruent segments. So the midpoint, I take the two x coordinates of P and Q and add them together and divide by 2. That's my x value. And to get my y value of the midpoint, I add my y coordinates together, y sub 1 plus y sub 2 over 2. So finding a midpoint, if I have segment AC, and I know that A is located at 5, 2, and C is located at 7, 8, I'm going to use the midpoint formula. Right, so here 5 is x sub 1 and 7 is x sub 2. Here 2 is y sub 1 and 8 is y sub 2. So I just plug those in. 5 plus 7 is 12 divided by 2 gives me 6. 2 plus 8 is 10 divided by 2 gives me 5. So the midpoint of this section, segment, would be the point 6, 5. Woohoo! All right, try this one. Okay, hopefully you got the midpoint of 1, negative 1. There's the work for the midpoint if you weren't sure how we got there. Basically add the x coordinates together and divide by 2. Add the y coordinates and divide by 2. All right, distance formula. This should also look familiar, right? This is the distance between 2 points, right? This is different than the distance equals rate times time relationship that we used in the last chapter. That's a different kind of distance. This is the distance between 2 points on the coordinate plane. So here I have my first point, x sub 1, y sub 1, and here's my second point, x sub 2, y sub 2, and this is the distance formula. Remember that that comes from the Pythagorean theorem, right? It has to do with the distance along the x and the distance along the y. So to get the straight line distance between the 2 points, the distance formula comes from the Pythagorean theorem. So here we're going to find the distance between 2 points in a word problem. So Matt's disc is 3 feet short and 2 feet to the right of the basket. On his first putt, the disc lands 4 feet beyond the basket and 1 foot to the left. If the disc went in a straight line, how far did it go? So basically we're going to want to model this situation first so we can understand what's happening. Here we're just going to assume that our basket is at 0, 0 to make it easy to put on the coordinate plane. So based on that basket, he started 3 feet short and 2 feet to the right. So 3 feet down and 2 feet to the right. So the point 2, negative 3. After he does his first shot or his first putt, it ends up 4 feet beyond the basket and 1 foot to the left. So we're asking if it traveled in a straight line from where it started to where it ended up, how far did it go? So we want to find the distance between the point 2, negative 3 and the point negative 1, 4. So again, remember these are our points. Does not matter which one I call 1 or 2, but in this case we called 2, negative 3 our first point, so that's x1, y1. And we called negative 1 for our second point, x2, y2. So I start out with the quantity x2 minus x1 squared and y2 minus y1 squared. Notice they have their parenthesis in the wrong place here, so that negative should be inside the parenthesis, negative 1 minus 2. So that gives me negative 3 quantity squared, which is, if we show the step in between here, that's 9 plus 49. That gives me the square root of 58, which is about 7.6 if I round to the nearest tenth. So the distance between those 2 points on the graph, his first point where he started and where he ended up, that distance was about 7.6 feet when he did his first shot. Okay, you guys try one. The answer here should be C, 22.8 feet if you rounded. Here's the work. The most important thing here is making sure you get your points correct. So the starting point was -4, -18. 4 feet to the left, 18 feet short of the basket. It ended up 5 feet to the right, so that's my X value, and 3 feet beyond or above the basket. Then this is how I plug into the distance formula, and I get the square root of 522, which when I do that in the calculator is about 22.8 feet. Do not forget your units, of course. All right, example 3, and this is the last example actually for this section. It's a pretty short section. In this example, we use midpoint and distance together in the same problem. So it says, a coordinate grid is placed over a drawing of Nita's patio. The grill is located at 2, -3, so that's going to be important. A flower pot is located at -6, -1, and a picnic table is halfway, that should automatically make you think midpoint, halfway between the grill and the flower pot. And then what it's actually asking is, in the coordinate units, how far is it from the grill at 2, -3 to the picnic table? But the problem is we don't know the coordinates of the picnic table. So this is 2 steps. 1, find the coordinates of the picnic table. 2, how far, find the distance from the grill to the picnic table. So we're going to do the midpoint first. The midpoint to find the coordinates of the picnic table. So that's halfway between the 2 points that we have, right? We have the grill is at 2, -3. We have the flower pot at 6, -1. And here we're just using the midpoint formula. -6, -1 I meant. So 2 plus -6 over 2 and -3 plus -1 over 2. We end up with our picnic table being located at -2, -2. So this is the coordinate for the picnic table. Now I want to know how far it is from there to the grill. The grill is at 2, -3. The picnic table is at -2, -2. So we just do the beautiful distance formula. And when we simplify that, we get the square root of 17, or about 4.1 units. So that would be C. Since this was a multiple choice at the beginning, it was a standardized test item. C, 4.1 units. All right, and here's the last one for you guys. Your answer here was 5.8 units. And here's the work. Notice in part 1, I did the midpoint between the gym and the lab to get the office. And in the second one, I did the distance from the office to the lab, which is about 5.8 units. And that is the end of this section. This is definitely the shortest section of the chapter, so enjoy it, and I will see you in class to practice and introduce the idea of conic sections.